Okay, go.
A says, is the speed of the particle increasing or decreasing at time t equals 5.5? Give a reason for your answer. In order to find whether the speed of the particle is increasing or decreasing at t equals 5.5, we use both the velocity and acceleration formulas. When we plug in 5.5 for t in the velocity equation, it comes out to negative 0.4534. Because velocity is negative, we know that the particle is going backwards at 0.4534. The negative acceleration that is determined by plugging in t equals 5.5 into the acceleration formula tells us that the particle is being pulled backwards at negative 1.359. Thus, the speed of the particle is increasing in a backwards motion.
Now it is.
Okay, B says to find the average velocity of the particle for the time period 0 less than or equal to t less than or equal to 6. So you do the phase formula, which is 1 over b minus a, so it's 1 over 6. Then you do the integral from 0 to 6 of 2 sine e to the t over 4 plus 1. Then you plug that in the calculator, and then you get 1.949. For C, you have to find the total distance traveled by the particle from time t equals 0 to t equals 6. So you do the integral from 0 to 6 of 2 sine e to the t over 4 plus 1 inside of an absolute value sign, because you have to find the total distance, and when you plug that into the calculator, you get 12.573.
For 0 is less than or equal to t, which is less than or equal to 6, the particle changes direction exactly once. Find the position of the particle at that time. In order to find when the particle changes direction between t equals 0 and t equals 6, we plug in the equation for velocity into y equals and press graph. We look at the particle's movement between t equals 0 and t equals 6. The direction changes from backwards to forwards once at about 5. But we need an exact number, so on the calculator we go to second trace and find the 0. What's that? 2. The particle changes direction at t equals 5.1955223. Now we must find the position of the particle. We use integral from 0 to 5.1955223, 2 sine e to the t over 4 plus 1 to find the antiderivative of velocity, and plug this into the calculator. This equals 12.1348, but because in the problem it says that x of 0 equals 2, we know that the particle started at 2. We then add 2 to 12.1348 and get our final answer of 14.1348.